My name is Fernanda. I'm a professor at the Federal University of Santa Maria in Brazil, and I also work at the Power Electronics and Control Research Group. I work mostly with power electronics and control, so the application of power electronics and controls for grid-connected systems, renewable energies, microgrids, modulation of multi-level converters, and also model predictive control. One of the main advantages of working with Typhoon and the solutions that Typhoon HIL provides is that we are able to first validate our controllers without the need to have the full hardware of the system developed. So we can have this pre-validation of all the controllers, all the firmware, and then we can make sure that everything is working properly before going to the full experimental setup. And this really saves us time and is also less expensive, and we are able to validate our controllers and modulators under some different conditions that we are not able to fully implement on the lab due to restrictions on the equipment that we have. So Typhoon also really speeds up this process of testing and validation of controllers and modulators. Hardware in the loop and controller hardware in the loop is really interesting for the students, especially for graduate students, master and doctoral, because they are able to have a more practical experience instead of working only with offline simulations. Of course, this also applies for undergrad students because they have this possibility of earlier on starting to develop the skills that they will need in order to work with complete hardware setups when they move into their master, PhDs, or even when they go into the industry. I think that Typhoon Sim is an amazing tool because it now allows us to use Typhoon solutions from the early stages, like from the early offline simulations, to validate the first designs of the controllers and the modulators, and then with the same schematic, with the same tool, we can move forward to a hardware-in-the-loop solution where we can have our C codes implemented in a C block, and then further on we can change the C block for an external DSP and work with controller hardware in the loop. And then finally we can move forward even for power hardware in the loop, or then with a full hardware validation of the systems. So I think that this complete integration from offline simulation to complete hardware validation, be it with C-HIL or P-HIL, it's really important because we can use a single tool to pass through all these different design stages of the converter. On the personal side, I have made some great friends in Typhoon, and it's really good to have this closer relationship and partnership with the Typhoon team.
Check the video description for more resources on this topic, including how to download and get started with Typhoon HIL Control Center for free. You can also visit HIL.academy to access free courses, expand your HIL testing skill set, and get certified. Subscribe to our channel to get notified about new content.